Well, in this session, we are going to talk about Bayes' theorem that is based on reverse probability. See, we are given a sample space and that E1, E2, E3, E4, En are n mutually exclusive and exhaustive events. By the word mutually exclusive, we mean that they do not have E1, E2, E3, they do not have any common sample points. These are mutually exclusive, and by the word exhaustive means if we take the union of all these events, then we get the sample space. We can say that these are the partitions, also known as E1, E2, E3, En are the partitions of sample space. Partitions means if we unite all, if we take the union of all, we are going to get the sample space, and there is no common between any two pairwise. These are pairwise disjunct. Okay. So if A is an event, which can occur, A is an event which can occur with either with E1 or E2 or E3 or even or E4 or En, then this probability, if we are given that A has already occurred, if A has occurred, if this information is given that A has occurred, then the probability that it is occurred with EI, that is probability of EI given A is given by this formula. Let's try to prove it with the definition of conditional probability. See, we are interested to find the probability of EI given A. Alright. By the definition of conditional probability, this probability will simply be equal to probability of common, probability of intersection of these two events divided by probability of that event which has already occurred. Now we talk about total probability of that A, that is PA. If I am interested to find the total probability of A, that is PA, then I know simply here we can say A is equal to this union, this union, this union, this union, this. If we take the union of all these mutually exclusive, these are also exclusive events, then I'll get A. So A actually is A intersection E1 union A intersection E2 union and so on up to A intersection En. So obviously probability of A will be equal to probability of A intersection E1 plus probability of A intersection E2 and up to probability of A intersection E. Okay. Because these are disjoint events, so obviously probability is equal to the sum of these. Okay. So now probability of A will be replaced by probability of A given E1 plus probability of A given E2 plus and so on to probability of A intersection E and the numerator is probability of EI intersection A, which is equal to probability of EI, probability of A given EI. Here probability of E1 multiplied by probability of A given E1 plus probability of E2 multiplied by probability of A given E2 and so on up to probability of En multiplied by probability of A given E. This is what reverse probability. Let's take an example. Suppose we are having two bags. Let's take a question from Ncert textbook. Suppose we are having question number 2 on page 556. Question 2 of exercise 13.3. A bag contains 4 red and 4 black balls. 4 red and 4 black balls. This is bag 1. Okay. Another bag contains 2 red and 6 black balls. The bag 2 is containing 2 red and 6 black balls. One of the two bags is selected at random. So if first bag is chosen, then second cannot be chosen, and if second bag is chosen, then first cannot be chosen. That is, these events are mutually exclusive and exhaustive. There are at a total 2 bags. Out of these two, if one is first is chosen, then second will not be chosen, and if second one is chosen, then first is not chosen. That means these events are mutually exclusive and exhaustive. Now something has already happened. A has taken place. Let's see what happened. One of the bags is selected at random and a ball is drawn from the bag. One of the bag is selected at random and a ball is drawn from the bag. Well, there are 2 bags. Suppose selecting the first bag is event E1. Let E1 is the event of selecting bag 1 and E2 is the event of selecting bag 2. Now one of the bags is selected at random and a ball is drawn from the bag which is found to be red. Now it is known A is an event. Red ball. Red ball can either, this red ball can be either be from bag 1 or from bag 2. And A is the event of drawing the red ball. One of the bags is selected at random and a ball is drawn from the bag and which is found to be red. A has happened. We are known, it is known that A is, now it is known that A has taken place. Find the probability that the ball is drawn from the first bag. What is the chances that this drawn ball which we have got is from the first bag? So here we are to find probability of the drawn ball is red. It is known, and we are to find what is the probability that it is drawn from the first bag. Here, selection of bags is equally likely. Yes, both the bags are having equal probability. There are at a total 2 bags. So 2 out of 2 each has equal probability. Suppose there were 2 bags, then 3 bags, then total number of bags is 3 and all are equally likely. 1 by 3, 1 by 3, 1 by 3 the probability would. Okay. Now probability of, we need this formula, we need probability of A given E1 and A given E2. A given E1 means probability of getting a red ball. E means getting a red ball. Red ball given that which bag is chosen? E1. Bag 1 is selected. Bag 1 is selected. Okay. If bag 1 is selected, how many balls are there in bag 1? Total 8. Out of these, how many red balls are there? 4. So, if the first bag is chosen, if it is given that bag 1 is chosen, then the probability of getting a red ball will be 4 by 8. Similarly, probability of A given E2 is probability of getting a red ball when bag second is chosen. Okay. If the second ball is chosen, total number of balls here are 6 plus 2, that is 8. Out of these 8, how many red balls we have? 2. 2C1, that is 2 simply. Right. This is the problem. Now, by Bayes theorem, probability of, we are interested to find the probability this E1. What is the probability that it has come from first? E1, E1, A is equal to probability of E1 multiplied by probability of A given E1 divided by, since there are only two partitions, so A1, E1 and E2. If we had three partitions, then E1, E2 and E3. Right. So this is probability of E1 multiplied by A given E1 plus probability of E2 multiplied by probability of A given. What it gives? Let me write it here. Is equal to probability of E1. Probability of E1 here is half multiplied by A given E1, that is 4 by 8, divided by the same term, this is half into 4 by 8 plus probability of E2 is half into the probability of A given E2 is 2 by 8. Do not cancel it, because here you can see the LCM is, this is 4 by 16 and here it is 4 by 16 plus 2 by 16. So we will get simply 4 upon 4 plus 2 if we cancel 16. If we multiply both the numerator and denominator by 16, so 4 upon 6, that is 2 by 3. So 2 by, if the drawn ball is red, then 2, 3 is the probability that it was drawn from the first one. This is how Bayes theorem works. Well, we have taken one more question. An insurance company insured 2,000 scooter drivers, 4,000 car drivers and 6,000 truck drivers. The probability of an accident is 0.01, 0.03 and 0.15 respectively. Means if the driver is a scooter driver, then probability of accident. Probability of accident, if the driver is a scooter driver, is this. Probability of accident, if the driver is a car driver, is this. And for the truck. One of the insured person meets with an accident. Means now it is known. This A is known. One of the person has, see the Bayes theorem. E1, E2, E3 are some partitions. E1, E2, E3. That is either the scooter driver. Let E1 is the event that the driver is a scooter driver. E2 is the event that it is car driver. And E3 is the event that it is a scooter driver. So this is the event A, that is meeting an accident. So a car driver can meet an accident, a scooter driver can, and a truck accident can happen with this or this or this. So these are mutually exclusive and exhaustive events. So how we start the question is, let E1, E2, E3 are the event that the driver is a scooter driver, first scooter, car, truck driver respectively. So probability of E1. How many total drivers we have? Total number of drivers, if we try to find total number of drivers, 2,000 plus 4,000 plus 6,000. 2,000 plus 4,000 plus 6,000. Out of this, how many scooter drivers we have? 2,000. So this is 2,000 upon 12,000. That is 2 by 12. Well, probability of E2. The total drivers are 2,000 plus 4,000 plus 6,000. Out of this car drivers are 4,000. So this will give us 4,000 upon 12,000, that is simply 4 by 12. Probability of E3, the driver is a truck driver. So this is simply, there are 6,000 truck drivers, so 6,000 upon 12,000. 6,000 upon 12,000, that is 6 upon 12. We are not cancelling. Actually, we will take the LCM as 12. Why? Now, probability of A given E1. We are given probability of meeting an accident given that the driver is a scooter driver. Probability of meeting an accident if it is a scooter driver. So this is 0.01. Also, probability of meeting an accident if the driver is a car driver is 0.03. And probability of meeting an accident if the driver is a truck driver is 0.15. Now by Bayes theorem. Now required probability. What probability we need? A has already happened. It is known. What is the probability that it is a scooter driver? That means E1. E1 is the event that the driver is a scooter driver. Simply, this will give us probability of E1 multiplied by probability of A given E1 divided by probability of E1, A given E1 plus probability of E2, probability of A given E2 plus probability of E3, probability of A given. Let's put the values. Probability of E1, that is 2 by 12 into the probability of accident, that is 0.01 upon probability of E1 2 by 12 into 0.01 plus probability of E2 is 4 by 12 into 0.03 plus the probability is 6 by 12 into 0.15. Now this will give us 2 by 12. 2 by 12 into 1 by 100. This is 2 by 12 into 1 by 100 plus 4 by 12 into, this will be 3 by 100 plus 6 by 12 into 15 by 100. So this will give us, I'm writing it here, the required probability, that is probability accident has happened. What is the probability that it is a scooter driver? Probability of E1 given A is equal to final calculation C. 1200 will be cancelled out, or we can write 2 upon 1200 upon 2 plus 4 3s are 12 upon 1200 plus 6, 15 6 are 90 upon 1200. So you cancel 1200 after taking the LCM. 2 upon 2 plus 12 plus 90, that is 2 upon 900, 100. 4, that is 1 upon 52. That is the answer. That is the required probability. If the accident has taken place, the probability is 1 by 52 that the driver is a